Hello students, welcome you for the video lecture on line codes. Outline for this lecture series: baseband transmission, what is meant by line code, what are the properties of line code, and types of line codes. What is meant by baseband transmission? If a digital signal is being transmitted, it occupies the entire bandwidth of transmission in the network media to transmit that particular digital signal. This is called as baseband transmission. So if bit 0 is being transmitted, it occupies the entire bandwidth of the network media. And this baseband is a bidirectional communication which allows the computers to send and receive the information on a signal cable. So what is meant by line code? Line code is a baseband digital modulation method. It is also called as digital data transport. The amplitude and discrete information are being conveyed as a digital signal 1 and 0. Therefore, line code is defined as a waveform pattern of amplitude and current values represented in form of binary data 1 and 0 transmitted on a transmission link. Why do we need to go for line codes? We are in the digital communication era, all the information available as a raw data is an analog signal that has been converted in various formats of discrete nature. So this discrete nature available signal have to be transmitted in order to understand for a digital communication device in mean of waveforms. So we need to represent waveforms in representing a discrete signal, which is a information. And all the channels available are a band limited channels. In band limited channels, there are chances of the signal getting dispersed. Dispersed is nothing but broadening of your pulses. So one information can overlap with the next available information. So we know that once overlapping occurs, as we have studied in communication theory, because of the Nyquist criteria, the signals are distorted, which creates the intersimple interference. What are the properties of line code? We should maintain the transmission bandwidth lower, power efficiency lower, error detection capability should be there, evaluate the power spectral density, transparency should be there in sending and receiving the information. What are the different types of line code? Basically, line codes are classified into 4 types. We call it as unipolar, polar, bipolar, and Manchester. What is a line code? Line code is going to be representing voltage, current, or photons in terms of digital data 1 and 0s transmitted over a channel medium. So you can represent your 1 and 0 either in unipolar, polar, bipolar, or Manchester type of coding. So how do we represent these line codes? So first we'll start with unipolar. Don't worry about NRZ and RZ. We'll only talk about unipolar. Unipolar, the other name is going to be on and off keying. In unipolar, bit 1 is represented as plus A volts. Bit 1 is represented as plus A. Bit 0 is represented as 0 level. This is unipolar, on, off. Next we go for the polar. In polar, bit is going to be represented as positive bit 1 will be represented as A volts. Negative bit is represented as negative A volts. So unipolar and polar, you can find out the difference. In unipolar, bit 1 is A volts. Bit 0 is 0 volts. Whereas in polar, bit 1 is A volts plus A, bit 0 is negative A. What is bipolar? Bipolar is going to represent bit 1 as plus and minus A. Bit 1 as plus and minus A. So you can find out alternatively you will have bits as represented positive pulse, negative pulse, positive pulse, negative pulse. Bit 0 is represented as 0 volts. So how do we differentiate now between the other two terms called as NRZ and RZ? So NRZ is called as non-return to 0, RZ is called as return to 0. So if you take a NRZ pulse, you can find out from polar and bipolar, polar and unipolar. All the pulses of NRZ will occupy the entire time period. This is one time slot. In this time slot, if the full pulse, either it is 1 or 0, if it is fully occupied, we call it as it's not returning to 0 value. Whereas in RZ, we assume that it occupies only half the time period. It occupies only a smaller time period. And after that, it will return to 0 value. So whenever you have a bit 1, half the time period, it will send the information and it will be returning to 0. Bit 0 will maintain in the 0 level. So NRZ occupies lesser bandwidth than, RZ occupies lesser band than NRZ. So to evaluate the signal in terms of power spectral density for a line code, we need to review the signal energy and power calculation. So what is energy? Energy is going to be the mean square value of the signal input. If it's a complex signal input, you differentiate with respect to dt parameter. Power can be calculated if it is a real or a complex signal with respect to the limits minus t by 2 to plus t by 2 with the average value of your energy signal. Therefore, the signal power is defined as the average mean square value of your signal input. In order to represent the signal in terms of power spectral density, I am going to take an example as human speech. The signals are available in time domain. We call that signal as x of t. All this I have recorded is a voice message for 15 seconds. A spectrum of voice signal is recorded for 15 seconds. This is how the signal will link into it. It's a time domain signal. But to have a mathematical evaluation, we need to convert the signal into a frequency domain. So this technique is being taken over with respect to Fourier transform, what we have done it in mathematics. The frequency domain will occupy with a frequency value from 0 to 4000 Hertz. So if you record for 15 seconds, you are getting the frequency to be occupied from 0 to 4000 Hertz, and this is the decibel value which says about what is the volume of your sound. And from the frequency domain, I can evaluate what is the power spectral density of the signal. So how to calculate the power spectral density? As we all know, power can be calculated. Now I have converted into a Fourier transform, so I'll get it as GT of F. Spectral density is being calculated with respect to the Fourier transform of the signal and the average value of the time duration. So the unit for your power spectral density is going to be volts per hertz. Volts per whole squared per hertz. The power spectral density gives the variation of the signal strength at each and every point of your function frequency. So from here we come to know that baseband transmission is the important one for characterizing a line code. Line code is going to represent ones and zeros in a digital way, which represents voltage and current value in a discrete format. And for transmitting a line code, we should have a small transmission band. The power efficiency should be low. Transparency should be there in transmitting and receiving the data. And there are 4 different types of basically line codes: unipolar, polar, bipolar and Manchester. The mathematical evaluation of the line code carries over with respect to the parameter called as power spectral density. So this lecture will say us about the basic information on the line codes. The continuation of your video lecture series will talk about how to evaluate the power spectral density of various line codes. Thank you.